Hello and welcome to Chaos and Caffeine. And this morning has been multiple hours of chaos while I argued with that piece of shit known as GPT-5. So just to get past all the hype BS that everybody's put up, and just so you're aware, I've held off because, I'm supposed to drink my first cup of coffee during this podcast. Today we're going to cover, forgot the props because I've spent hours arguing with simple stuff with what was supposed to be a better system, which went so far backwards from the other GPTs as to be ridiculous. It seems to have solely been for the effort to attempt to get stock prices up. But that's neither here nor there. Allegedly. But in any case, I'm glad to see that there's been some court cases recently where false claims are being addressed. So in any case, let's get back to our story. Yes, I'm very frustrated. You could see from the title that was probably the 40th image that I had made at about 5 minutes an image, where it used to take 1 minute and only one or two tries. In any case, so a week before last weekend, we were in Norfolk. Well, actually, we were in Newport News, but went over to Norfolk on the last day of the Vibration Institute meeting to see the Battleship Wisconsin. Now, several of us were motor repair shop folks, and we went there to see the motor repair shop that's on board. I saw it several years earlier. I'm going to try to find those images and get those up here because it's kind of cool because it looks exactly like the motor repair shop, or very, very close to the motor repair shop that I had on the Theodore Roosevelt. So today I'm doing the Navy thing. So the whiskey, we went down to the ship store there and discovered that they had Wisky Gun Barrel blend coffee, which is specifically for the Battleship Wisconsin, which is BB64, commissioned in 1944. This is the museum coffee. Claims to be a medium dark roast Colombian and Brazilian blend with notes of chocolate, granola, caramel, almonds, and citrus. Quite the interesting thing. What is interesting also is they used a roaster by the name of Rich Port Coffee out of Norfolk, Virginia, and this was actually made this was actually roasted several days before we arrived there. So this is basically just about a week old. So the first thing I'm going to do, it's a little bit different. I'll explain what we see in the coffee here in a second. Is it's definitely pretty aromatic. Now, just so you're aware as well, last week in episode 3, the one in the between is 4, which I'm going to launch alongside this one. It was actually the announcement for this one. In 4, between 3 and 4 in this one, I've still been drinking the shop floor coffee. There's just something about the taste. It was really interesting. The hydraulic fluid. I recommend you go back to that episode. I'll have that at the end, and go try it. I made a little fun of it, but that had to do with a conversation the owner and I had. But it was really good. We're going to try some of their other blends sometime in the future as well. So I've got a lot to cover. In any case, so the ship was commissioned in 1944. I'll show some pictures from our visit because we had the really cool experience of watching a re-enlistment while we're at it. The other thing that really got me going with the GPT-5 was I said, you know what, I'm going to try doing a script this time, and I haven't started it yet. And that script was going to be on maintenance all the way through modern times. It's terrible. It's awful. I'm going to follow along with it, but I am most definitely going to deviate from the script it provided because, wow. And companies are using this to make decisions. Yeah. I know that my programmers who've been using it to support have been a little frustrated. But this is not supposed to be a GPT conversation. I've gone well beyond where I should have. So let's go ahead and try the coffee. Now, you'll note in the picture that I'm going to put up there that it's got an oil slick. So perfectly good for a battleship. I'll keep the bag on the shelf as a souvenir. I'll do my best to drink this. Not impressed. That's a first. It's definitely, I wouldn't even call it Navy coffee. Navy coffee has a tendency to be a bit thicker. This one does not stick to the sides like the last one. And it is definitely bitter. Could use a pinch of salt. But oh well. So there we go. So let's get into this thing. Bits of stuff in it too. The grind is like what I would do for like a Turkish coffee. Extremely fine. Might even try it as a Turkish coffee, just because the milk and sugar would make it taste better. I'm not impressed. Sorry, guys. So obviously made for. Well, I mean, it wasn't exactly expensive either. And this bag at 8 ounces, costing me in a museum shop $12. So I think they just yeah. So I don't think it's meant for drinking. In any case, so we visited the Wisconsin on a Friday. It was nice and hot, and you could swim through the air. But that's besides the point. Perfect Norfolk day, basically. I served in the Norfolk area in the 1980s on the Roosevelt, Theodore Roosevelt. That's the hat. This is a different hat than my original, which is hiding somewhere with my chevrons on it. So when we took a look at it, I'm going to semi-follow the script. We were able to feel some history beneath our feet. Yeah, we walked through the museum. Yeah, we hurried towards the ship. The fun bit. Got in, I think we got in, Chad, who was with us, clocked us in at about 6,000 steps by the time we were done, because that vessel is 887 feet long, 45,000 tons displacement of armor and firepower. So you had two big sets of guns up front that could fire shells, not the size of, but the weight of a small vehicle, over 20 miles. So it would sit offshore and just pound whatever into dust or glass, depending on where it was. And so you had two sets of 3 guns up front, one set in back, and then all kinds of anti-aircraft and anti-ship, and after they did some refits, other weaponry on board. But none of that power mattered without reliability and maintenance. Thousands, yes, over 5,000 crew supposedly able to, hard to find the statistic, but supposedly could manage about 5,000 crew of sailors labored below decks, checking gauges, tightening bolts, inspecting turbines, scrubbing corrosion. Every system had to be worked on. Now, even now, with it sitting in port, pier side, a big part of their issue was maintenance. So we walked through not just the upper decks, but also the maintenance deck, which was right below the top deck, and then the weapons deck was below that. The Wisconsin wasn't just a warship. She was a living monument to the hidden work of reliability, and that story stretching from ancient irrigation canals to modern digital twins is the story we'll explore today. Basically, humanity's unbroken battle against failure, such as GPT-5. Oh, did I say that out loud? I am very frustrated. Let's travel back to the very beginning. In Mesopotamia, now this is true, around 3000 BCE. Now, this is recorded history because there's no way you couldn't be doing some form of maintenance prior to that time. I mean, there were wars and battles, and primarily, if you were any type of surviving warrior tribe, I'm still going to drink this crap, but I was going to have fun and try to stand a spoon up in it, but it's, yeah. So, anyways, recorded irrigation repairs on clay tablets, maintenance logs 5,000 years ago, basically. And I swear some of the plants we've been into recently use the same thing. Crops depended on canals being cleared of silt. If they failed, entire cities starved. In Egypt, the Nile was both a life and risk. Irrigation systems were checked and maintained constantly, primarily because there was a lot of silt that came down and set up the delta there, making it one of the richest farmlands in the Middle East at the time. That's not in the script, but really, I'm a medieval and ancient history buff, so that area was so rich, and that's part of the reason why Egypt was so powerful. They had to keep dredging that to allow small ships and their flat-bottom boats to get through and around there. Even the pyramids themselves, while built for eternity, required ongoing upkeep with teams repairing erosions and cracks. The pyramids at the time, the big ones, did not resemble exactly what they did today. We're actually looking at the guts of it. There was an outer shell that needed to be maintained. The Romans took maintenance to a completely different level. Roads stretched across Europe, and aqueducts carried water for hundreds of miles. Entire crews, curators viarum for roads and curators aquarium for water, were appointed to inspect, repair, and monitor. Basically, your original titles for reliability and maintenance engineers. Roman military camps carried portable toolkits for weapon upkeep. Now, some of that had happened beforehand as well, but this is where, because I had asked, and I did verify all this stuff, but I had asked, when did we start, historically, where were we recording maintenance? So basically, the reliability was simple. The roads were so important to the Romans for communications, maintaining things, moving troops rapidly. That was one of the powers behind Rome, was the Roman roads. I mean, they could move entire legions very, very quickly. They also had the ability to communicate very, very quickly. If aqueducts broke, cities withered. There was also sewage systems and everything else that were all maintained. Now, when Rome more or less fell in around 200 to 300 AD, a lot of places were left on their own, and everything collapsed. We call it kind of the medieval ages, or heading into the dark ages, right? So people actually missed the Roman engineering and maintenance and everything else. In the Middle Ages, maintenance was less centralized but no less vital. Castles and fortifications required constant inspection. Stonemasons patched cracks, carpenters replaced gates, smiths reforged weapons. Even the maintenance of shoes for horses and all kinds of other things, armor for knights and other things. Even individuals who would be recruited and forced into having to take part in whatever warfare was going on had to maintain their own equipment. On the seas, Venice built the Arsenale di Venezia, a vast shipyard that's pioneered assembly line production and systematic maintenance centuries before Henry Ford. Ships were built, deployed, and cycled back in for overhaul. Without these cycles, fleets basically rotted in harbor. What's interesting about that is referring to Henry Ford for the assembly line and interchangeable parts. That actually falls earlier with armories and the like, with other people that came up with methods to make interchangeable parts, which allowed for easier maintenance of these weapons, guns, and so on. So all of that started into things like sewing machines and so on, where they had the interchangeable parts for sewing machines to repair them. That was well ahead of Ford. Ford was the first one to take advantage of that to produce a car. Guilds set strict quality codes. So basically, that's why it was hard to get in and stay in guilds, and they would actually punish each other over poor quality because it would damage the reputation of the guild. That meant, by damage reputation, meant reduce the power of the people that led the guild. So maintenance was extremely, and quality was extremely important for the maintenance of individual power groups. Okay, so a blacksmith or mason's reputation depended on reliability, as did their whole guild. Failure wasn't just a technical issue, it was personal, moral, and an impact on that guild's power. In the Renaissance, engineering, of course, advanced significantly as well as art. Leonardo da Vinci sketched not just machines, but also made maintenance notes for how to take care of them, designing with repair in mind. So why we've gone backwards, who knows? Reliability was shifting from craft to system. Now, what was interesting about that statement is that that we looked at that time as how do we maintain the equipment, even though it was built robustly and everything else. How do you take care of it? Versus now, where it's assumed because of software simulation that somehow everything's going to live forever. Now we get into the industrial age. The Industrial Revolution exploded with power and danger, of course, because now we had large, powerful machines flinging stuff around. There was no such thing as guards. You can go to the Smithsonian and see some of this stuff. It's incredible. Steam engines turned factories, locomotives crossed continents, and mines dug deeper than ever before. And the biggest, people don't realize this, but one of the biggest boons to moving the Industrial Revolution wasn't the cotton gin, it was pumps. Yeah. When you look at history, pumps had the steam-driven pump for dewatering mines was so incredibly important in order to get the ore necessary to do everything else. And while everybody was going after gold, it was steel and copper and things like that were far more important. Tin made entire countries. There was wars over tin, things like that. But failure was constant. Boilers exploded with devastating force. As a matter of fact, one of the biggest, most powerful companies in the U.S. In the early days was Hartford Boiler. Railroads demanded constant rail alignment, lubrication, and replacement of worn axles. Factories employed millwrights whose sole job was to keep the machines alive. And there was lubrication specialists, and lubrication might have been animal fats and things like that. That's everything else. It wasn't until later that we got the other types of lubricants that we use now. Whale oil was used for, light and all kinds of other things that we don't think of these days. For the first time, safety laws were passed. Now, this is in the 1800s still, but there were so many deaths attributed to improper, safety or maintenance that, people would lock their employees in, and then a fire might start and it would kill all of the employees, things like that. Governments realized unchecked failure killed workers and cost fortunes. It was more the cost fortunes at the time that was important. Preventive maintenance was born, not waiting for the catastrophic break, but checking ahead. Now, in some history books and maintenance, they talk about the world wars and preventive maintenance. That's not exactly true. By the mid-1800s, railroads had maintenance yards with round-the-clock inspections. Trains were reliable because thousands of workers made them so. Reliability was becoming recognized not as a luxury, but as a necessity for progress. World War I was a turning point. This was the first war of machines with tanks, trucks, planes, machine guns, and those machines failed. So that was also when cavalry was used all the way up until World War I, and then they came up against tanks and armor, and that kind of ended it. I mean, they did attempt cavalry in World War II, but really wasn't as effective. Machine guns jammed in mud. Soldiers developed drills to clear them under fire. Biplanes needed inspection after every few hours aloft. Pilots carried mechanics as trusted crew. So there would be 2 seats and you'd end up with a mechanic. Armies developed manuals, inspection routines, and maintenance depots. Logistics became central. A tank was only useful if spare parts and fuel reached it. Reliability wasn't just mechanical, it was strategic. So we started into that World War I period where they borrowed from industrial engineering and started looking at logistics. Now, logistics has always been a thing because an army lived on its stomach, and if you didn't have the logistics, it just didn't survive. For the first time, engineers systematically studied why machines failed and how to prevent it. Reliability was no longer trial and error, it was science. So now we go past World War I. So World War I raised a lot of the questions. World War II gave the answers as bigger machines, submarines, and other things started in. Mass production created tanks, planes, ships, submarines. Maintenance schedules were standardized. Spare parts were stockpiled and moved by convoys. Now, I don't know if it'll mention this, of course, but one of the key things at the time was estimating the life of a component so that you could replace it. Matter of fact, a lot of those documents still exist. They've been scanned in and they're kept on the internet. So you can find libraries of mill specs, mill standards, et cetera, et cetera, et cetera, and some of the history. Excuse me. The Allies learned that logistics and repair were weapons in themselves. A tank knocked in battle might be back within 48 hours thanks to maintenance crews. This actually, timeliness from a political standpoint, one of the reasons that's been determined by several war colleges is the reason why Russia didn't just roll over Ukraine was the pure lack of maintenance of the equipment. So they basically stalled, broke, and everything else. The Ukrainians, on the other hand, had been maintaining equipment and actually had the maintenance buildings for a lot of the armored vehicles in their territory from back USSR Cold War days. So speaking of the Cold War, then came the Cold War. We had nuclear submarines, intercontinental bombers, which we've also been hearing about. Failure basically is unacceptable. You need precision. In order to have precision, everything has to be calibrated and maintained properly. NASA was also born in this era. Formalized reliability engineering, methods like failure modes and effects analysis and mean time between failures became standard. That's actually part of reliability engineering. Every system was designed not just to work, but to endure, meaning how can it be resilient to different conditions, especially critical systems. We had nuclear power, nuclear generation. All the nuclear age became really focused on reliability and maintenance. Now we get into more modern times. By the 1970s, reliability spread heavily into industry. Beforehand, some companies had maintenance, but really they focused on production, getting stuff out. And, this is the era where we're also talking about Deming, who brought concepts to Japan, such as total productive maintenance and the other effects that we use now. So TPM would allow operators to maintain their own machines. The concept was to prevent downtime before it began. What we know now is that requires very specific mindsets and culture in order to do that. So it's been effective in some areas where the culture allows for it, and not so well in other cultures where the goals are produce, produce, produce. Your pay depends on how much you produce. And of course, then maintaining the machines is nothing. Oh, I can get it through the shift, then the next guy's got to worry about it. And that concept keeps rolling on. I watched that in action in a steel mill when they had a failure issue with a particular machine. And what ended up happening was the operators would give that to the junior person because they wouldn't be producing as much, and therefore they wouldn't get the same bonus. Until we finally fixed the problem, then everybody wanted that machine. So airlines pioneered reliability-centered maintenance. Actually, they pioneered some concepts prior to that because of the 747, which was an extremely complicated machine. What most people don't realize is when I have a complicated machine, failure is random. Okay, we know that, we see that. Unfortunately, we still have marketing and articles and people that don't understand what they're talking about, throwing the bathtub curve up, which is actually an actuarial curve from the 1600s that was originally used by insurance companies, and they applied that against machines, thinking that's how machines survive, just like a human being. Infant mortality with random death and then wear out, meaning that you die of old age. Nowadays, it's representing less than 3% of all equipment, but everybody wants to apply it there. I call those folks kind of your vibe consultants, just like vibe programming. But that's neither here nor there. Let's continue on. Airlines pioneered RCM. So RCM was actually Nolan and Heap, who were the people who pioneered or oversaw the development of the reliability program at United Airlines for the 747 so that they could keep wheels up. So they were then contracted by the military, not just one branch, but by the military overall, to develop a product that discussed the importance of maintenance, which was produced and released in 1978 as the document reliability-centered maintenance. It then spread throughout the military and everything else. It was meant to maintain weaponry and aircraft. So you'll primarily find the certifications for RCM fall under NAVC and NAVAIR, which is the U.S. Navy's Sea Command and aircraft carrier / air command. So in any case, sensors monitored vibrations, oils, and temperature, giving early warnings of failure. Now, this I have a problem with, and that really condition-based maintenance that we used to call predictive maintenance, everybody has their name for it. Doing testing is meant to identify conditions that can be mitigated to avoid the whole concept of failure. Unfortunately, all of the fly-by-night companies that are popping up, even though they're valued at millions of dollars because of investors, they've all been pushing this whole concept that you have to detect failure. And if you're doing that, all you are is in a reactive program. You are not in condition-based maintenance or predictive maintenance at all. And I have very, very strong feelings about that because we were always taught you're identifying defects, but the defects are, okay, we have low lubrication, we have this condition, we have misalignment. These are mitigable problems to keep the machinery running. That's what you're basically checking the condition of the machine and doing maintenance to maintain the machine. Not corrective maintenance, but lubrication and things like that. The concept that ultrasound had has been very good. I have some issues with it, of course, but I have issues with everything. My job is a reliability engineer. My job is literally to look for everything that's wrong. But anyways, you would take your dB reading and you would see a certain value, you'd see an increase, you know that your lubrication was getting poor, so you relubricated at that point. So in any case, or like what we do, when we go out and we use electrical and current signature analysis, we're looking for conditions that if we correct them will reduce the energy consumption of that machine. we're not looking for the last minute failed bearing with chunks flying everywhere. Oh, look what we caught, that you can hear from a mile away already. And it's one finding of the 10 false positives that came along with it. But that's neither here nor there. Welcome to AI, which took me hours this morning to do this, which I should have just gone on here and just started talking and thrown a picture of us up standing on the Wisconsin. In any case, maintenance evolved from fixing what broke to predicting what would. Now that's the problem. That is not what it was all about. The whole concept was to identify conditions to prevent the breaking of the equipment. Otherwise, like I said, you're just in reactive maintenance to begin with. You want to correct the problems while it's cheap and easy, not when it's broken. Today, AI and IoT reshape reliability again. Of course, this is the position of GPT-5, which says you need to rely on GPT-5, I'm just exaggerating here, but it's basically saying AI is the end-all, be-all of maintenance, and the world is going to change, and AI predicts failures days or weeks before they happen. Yeah, it predicts failures, and I've seen pictures of it on LinkedIn. Look at this catch we had, big chunk out of the bearing. I mean, if you just had people walking by and they hear that, they could report it probably faster than that device. Reliability is shifting again from preventive maintenance to building resilient systems designed to keep working even under stress. Which basically means because we're allowing things to run to failure, you have to make them tougher and harder so that they can ride through those failures instead of dealing with the problems that are driving those failures in the first place, because there's absolutely no discussion in here about doing root cause failure analysis to go in when failures do occur, because that's what's supposed to happen. Every time you have a true positive with one of these devices and you pull out and the bearing's in pieces, ooh, we just caught this. Ooh, it's a wonderful success for our program. No, it isn't. It's a failure. You go to that point, you have failed. Back to the Wisconsin. As we went back, as I think about the ship, as we went through and we were looking at just the notes and bounds of information in there that specifically discussed the maintenance aspects for that vessel. From Mesopotamian tablets to Roman aqueducts, from steam engines to smart sensors, the message is clear. And we make smart sensors, don't get me wrong, except we do a little bit more behind it. We don't just go, ooh, there's a problem. It is built, it's maintained, it's the foundation of civilization itself. It was. Where we've gone right now is backwards. We are running backwards as we rely more and more on systems that are not performing real maintenance or condition-based maintenance. So that's my final message in that. In the meantime, they definitely need to maintain this crap. Sorry, folks. Like I said, it's kind of a cute coffee. I'll put it up on the shelf after I empty it and puff up the bag so it looks like it's got stuff in it. Maybe put sand in there. It might taste better. Ugh. Sorry, guys, and sorry to the roaster behind this. Luckily, I am going to finish the day off with my last cup of the shop floor coffee I got last week, because it definitely, even that little bite in it, I don't want to call it bitterness. It isn't. I literally couldn't put it. I wouldn't want to put anything in it. Like I said last week, you knew you were drinking coffee, and I throw that out to you guys. That was a surprise. I did not expect it, and I didn't expect to like it. And trust me, I like things like some of the ones we're going to talk about soon. And with that, I'm going to finish this here. I tried to keep these things to 10 to 15 minutes, but the history of maintenance takes a little bit longer, so hope you enjoyed this. I'm going to try to include some images as I go through here that'll be fun. Yeah, if you're having fun with some of the stuff that's coming out now, because we've tested the other tools as well, and we're not seeing much difference. I think it's all plateauing, which we'll see what happens as this energy stuff goes on, and one of those things will be my topic next week. And with that, have a great time. I'm off to save the world, and enjoy. Stay caffeinated.